All right, this video is on Earth's atmosphere. So we did a little activity in class about the atmosphere, about how high each of the different layers of the atmosphere are, but we didn't really get down into the nitty-gritty of what the actual atmosphere is. So we know it's a thin layer of gases that surround the Earth, but it has some really important roles. So Earth's atmosphere makes conditions suitable for all living things. It's able to trap the energy from the sun and keeps it around the Earth so that it keeps the Earth warm. And the Earth's warmth is what allows liquid to stay in its, or excuse me, it was what allows water to stay in its liquid form rather than its solid or frozen form. And it also protects from radiation and meteors, which we'll talk about in a second. So what gases actually exist in our atmosphere? So we have nitrogen, and contrary to popular belief that believe that oxygen is what makes up most of the atmosphere, that is wrong. Nitrogen is actually what makes up most of the atmosphere. It is 78% of the atmosphere is nitrogen, or N2. That means 2 molecules of nitrogen together. Oxygen is the other 21%, that's 2 molecules of oxygen together. Then we have trace gases. Now these are just other gases that can be randomly found in the atmosphere, such as argon, carbon dioxide, neon, methane, krypton, and hydrogen. So what else is in our atmosphere? Water vapor. So this I would think would be pretty obvious, as you guys understand that it rains. And when it rains, that means there is water vapor that is condensing in the clouds and coming down as liquid water. So water vapor is basically gaseous water, or water in its gaseous form, and it is invisible. Basically, trees are responsible for a lot of this, by the process of transpiration, which you might have learned about last year. Transpiration meaning the basically evaporation of water out of trees' leaves. So the tree gives off about 40,000 gallons of water vapor in a year, but that's not where the majority of the water vapor comes from. Most of it comes from evaporation over the oceans. And then ozone. This we talked a little bit about when you guys were doing your activity. The ozone, this forms when the lightning interacts with oxygen, so O2, in the air, and it creates a molecule with 3 oxygen atoms instead of 2. So ozone is actually 3 oxygens bound together, kind of like one here, and one here, all together in like a triangle, whereas the 2 oxygen atoms are just like this. So that is another thing, and we know that that can be found in our stratosphere. So it is a layer in the atmosphere. It absorbs UV radiation. So why we put on sunscreen? To protect ourselves from UV radiation, which can cause mutations. That's why we use sunscreen. The ozone layer protects us from the majority of those UV rays. However, some of them still get through, which is, like I said, why we use sunscreen. And it is also the area that is going to heat up the Earth. In other words, it's like the big thick blanket that keeps warm air in. So really quickly, I know that you guys did this already in your activity, but I'm just going to go over the layers of the atmosphere. We have the troposphere, which is the layer closest to the Earth. The altitude kind of differs depending on where you're at on the Earth. So if you are closest to the poles, it goes up about 8 kilometers. And if you are closer to the equator, it goes up about 15 kilometers. This is where the weather occurs. And as you move away from the Earth's surface, the troposphere, in the troposphere, the temperature decreases because the Earth's surface absorbs all the trapped heat. So there's not enough left in the actual troposphere. We know from the activity, the very top of it is called the tropopause. Then we have the stratosphere. This is the layer directly above the troposphere, which extends about 50 kilometers. So this one goes really high above the Earth. So it starts, like we said, at about 8 to 15 kilometers and goes up to about 50 kilometers. This is the area where our ozone layer is, which protects from UV lights, which kills plants, animals, and causes skin cancer in humans. And as you move away from the tropopause, so at the top of the troposphere, the temperature in the stratosphere increases because the ozone is trapping heat. So the very top of the stratosphere is called the stratopause. The mesosphere, so beginning at 50 kilometers and ending around 80 kilometers, this layer protects the Earth's surface from being hit by meteoroids. So this is the place where most of the meteoroids or meteorites burn up because of the friction with the atmosphere. As you move away from the Earth's surface, so the top of the stratopause, this layer decreases in temperature because we're starting to get pretty close to space. And the very top of it is called the mesopause. Now the very next layer, the last layer, is called the thermosphere. The thermosphere is actually divided into two layers when you talk about it. One of them is the ionosphere, which is the lower layer of the thermosphere. It begins about 80 kilometers and goes to about 500 kilometers, so it's really big. It contains ions and charged particles, and this is basically what allows us to have radio communication with the people in outer space, is the fact that this ionosphere exists so that there are radio waves to bounce signals off of. This is also the layer that is responsible for the aurora borealis, or the northern lights, or the aurora australis, which would be the southern lights, which we don't hear about a lot here, but they do exist. And then finally we have the exosphere. This is the outer layer of the thermosphere and basically the beginning of space. As you move away from the Earth and towards space, the temperature continues to decrease at this point. So here's the same thing that you guys did. So we have our troposphere, tropopause, stratosphere, stratopause, mesosphere, mesopause, thermosphere, and you see that it decreases and decreases and decreases. Air pressure. All right, so the definition of air pressure. Now, basically, it's a weight of column of air pushing down on an area. So if you think about it, the atmosphere is like a giant blanket around us. And as we move up in elevation or in altitude, as we move up, we have less of that blanket resting on us because we've moved through the layers of the blanket. So therefore, it's less air pressure. So when they say air pressure is the weight of a column of air pushing down on an area, well, that's the weight of the entire atmosphere. But if we travel up through the atmosphere, we're losing some of that air pressure because some of that air pressure is below us. So more dense air has higher pressure than less dense air. This makes sense. So air is made of molecules. I hope you all know that. Air is made of molecules, like we said, of some nitrogen, some oxygen, and all those different trace gases. And when you have really dense air, that means the molecules are really close together. And they can only be really close together if they're cool. Okay, because when they're cool, they don't really move fast. So when they're really close together, you get dense air because you have more molecules packed into the same amount of space. When you have lower air pressure, or lower density, that means that molecules must be moving really fast because when they move, they bounce off of each other and they spread out. And that makes less dense air. So as far as air pressure goes, we measure the density of the air, or how much is there. High air pressure means more dense air. Low air pressure means less dense air. The tool we use to measure air pressure is the barometer. So let's see here. I don't know if that's going to work. Oh, there we go. Okay. Okay, so basically, we can see, so here's our balloon. We can look at the volume of the balloon and the air pressure. So as we go up, you notice that let's first look at the very bottom. The very bottom, you see the volume is low, the air pressure is high because we have all this atmosphere pounding down on this balloon. Then as we move up, notice that the air pressure has decreased. We're increasing in altitude again. Look at the air pressure has decreased again because we have less atmosphere pounding down on this balloon. So a lot of the air pressure is below it, so it's less weight. And then look, the air pressure has gone down again as we increased again in altitude because there's less atmosphere pounding down and more below us. And less again. Right, and less again. So I hope that makes sense for air pressure. Okay, So how we measure air pressure is inches in mercury, and we do it with our barometer, which we can look at later. Pressure matters because they circulate and they move at different paces, and also they are responsible for weather. Air pressure is going to be responsible for weather. When we use National Weather Service or the NOAA maps later when we forecast weather, they're going to be found in millibars. Okay, so altitude, you guys should all know this is the distance above sea level. In Colorado, we live at altitude, which means we have less air pressure than us, or than our friends or loved ones that live at sea level. So the higher the altitude, the lower the air pressure. So if you go stand on the top of Mount Everest, you're going to have less air pressure on you than if you stand in Denver, or if you stand in Florida, which is at sea level. Okay, and this is just a fun little picture that kind of tells you what is located in different areas of the atmosphere. We have weather balloons, small planes, and the weather. So this is the troposphere. Okay, our radio waves reach all the way up here. Then we have the stratosphere. Notice the jets kind of fly between the troposphere and the stratosphere, and also you can tell, so most of this the density of molecules in the troposphere is pretty dense. And as we go up, look, it gets less and less dense because the air pressure gets less and less. So as we increase our altitude, air pressure decreases. You can also take a look and see that in the troposphere, it's made up mostly of nitrogen, oxygen, and carbon dioxide. I don't think you can see that, but carbon dioxide. In the stratosphere, it's got a lot of ozone in it. In the mesosphere, we have nitrogen and oxygen, and this is where our meteors burn up. Notice the density gets smaller and smaller. Then we have the thermosphere, where the molecules are very far apart. In the first layer, we have our aurora borealis and our ions, which is where the radio waves can travel up to. And then finally, in the exosphere, this is where things orbit us in space. So that would be our space shuttles, our satellites, all of our space stations, all that kind of stuff. So the energy from the sun strikes the thermosphere first and converts it into heat. So we do get a little bit of the heating up from all these different layers. So yeah, I hope that makes sense. Thank you.